20-1s, welcome to lesson 2, arithmetic series of our sequences series unit. Wow, lesson 1, long one. Sorry, it's just a fact of life. Like I said, most of the videos aren't that long. That one with the introduction, hey, suck it up, buttercups. You'll be fine. Otherwise, what we are looking at is today arithmetic series. Won't be quite as long, I know that for a fact. So, here we go. Yesterday we looked at sequences, arithmetic sequences, where we started with the value and created a list of numbers that had a common difference between each term. It got bigger by the same amount each time. Here we had a D value of positive 3. Each value in the list is 3 larger than the previous one. Well, today we're going to take a look at series. Now, series are very similar to sequences, except a series means we want the sum, the total of the list of numbers in our sequence. So it's like having a sequence, but we're adding them to get a sum overall. What's nice is, for this particular series, there's an example. The sequence would be 3, 10, 17, 24, 31. That would be the sequence, but the series is then asking for the sum of it. What's nice with this is our variables still mean the same thing. T1 is still the first term. And for this example, the first term is 3. So T1 hasn't changed. N still represents the number of terms. 1, 2, 3, 4, 5. So in this case, we have 5 terms. Note that the sum does not count as a term because that's the sum. Just the values being combined are your terms. D is still the common difference. How do we go from 3 to 10, 10 to 17, 17 to 24, 24 to 31? Each term is being increased by 7, so our common difference here is 7. And Tn still, in general, represents the last term. So in this case, our T of n value, the last term, is 31. But we could be specific enough to say that in this case, because there's 5 terms total, our T of n, or T5 term, is 31. 31 is the actual term number 5, the actual term in that position. So that hasn't changed. What does change with equations, or our variables for the equations, is this S at n. The S at n is saying it wants the sum of the first n number of values. So again, S at n is saying, hey, we're not sure exactly how many numbers are being combined or terms being combined, but the capital S is saying we want the sum of them. So for this example, this is saying we want the sum of the first 3 terms. So we could get the S3 value because we could say S3 is the sum of the first 3 values. 3 plus 10 is 13. 13 plus 17, this gives us a value of 30. So S3 for this particular series is 30. And S5, well, it's just asking for the sum of the first 5 terms. So it would be, well, in this case, S5, there are 5 terms. 85 is the sum of the 5 terms. So instead of just having lists of numbers, now we're dealing with series where we combine them. So if we take a look, page 5, I'm not going to go through how the formula is created. You won't be quizzed on it or anything. Basically, we come down to two formulas to calculate the sum of a certain number of terms. Still has the same kind of variables in it, okay? But we do notice that the two formulas differ a little bit. In this case, this formula is when the last term is known. So in this case, you know what T of n is. Whereas this formula, we don't know the last term. T of n is not known, so we need to use the n, the d, and the T1 in the formula. So, a little bit smaller formula, arguably easier to use, but only practical if the last term is known. Bigger formula, a little bit more work because you don't know the last term. So you have to utilize all the little parts in that formula. Basically, every question needs to be analyzed to figure out which equation works best. So, first example, we want to find the following sums. We want the sum of the first 34 terms. Now again, it doesn't state this in the questions, but this is always algebraically. Just making a great big list of numbers going, oh, okay, add 6, so add 6 would be 32, and add 6 would be 38, and add 6 would be 44, and doing this and finding 34 numbers and adding them up is not acceptable. You need to do this work algebraically using the formulas. So I still like to list what we know. We want the sum of the first 34 terms. What do we know? We know the first term is 14. What else do we know? Well, we know 14 to 20 plus 6, 20 to 6 plus 6. We know the common difference is 6. Is there anything else that we know? Well, there is. Don't forget, this S34 tells us that we have 34 terms in our sequence and our series, essentially. So it tells us what our n value is. We want 34 terms. Well, now we have to choose formulas. So we have formula 1, we have formula 2. Which formula should we use? Well, we don't know what the last term is. It goes ... We would have to do ... a whole bunch of times to get to T34, which we don't know what it is. So this case, here's the formula we need to work with, because we know what n is, we know what term 1 is, we know what d is, everything's there. So we just plug into that formula. S of 34, the sum of the first 34 terms, will be n 34 times 2 times term 1, which is 14, plus n, which is 34 minus 1, times d, which is 6. And all of that needs to be divided by 2. Now, there are different ways to approach this in some cases. Order of ops is what I use. I will divide by 2 as a final step because I will do all of the numerator calculations first. With that being said, some people will see the 2 and the 34 and say, oh, I can reduce the 2 and the 34 to be a 1 and a 17. That's possible as well. You need to make sure you're punching this into your calculator and you can get this answer on your own, not just writing down what I write. So I like to break it into steps using order of ops. So we have 34. I have to do brackets first. 34 minus 1 is 33. Multiply. 2 times 14 is 28. Plus 33 times 6 is 198. And all of that is divided by 2. So I like to show a step. It just helps me to break it into parts. Some students will try to punch all of that into their calculator at once. If you can do that consistently without making a mistake, you go for it. I like to break it into some smaller steps. Either way, the sum of the first 34 terms, finish it off, do my brackets. 28 plus 198 is 226. 34 times 226, then divided by 2, is 3,842. There's the sum of the first 34 terms in that series. List what you know, check. Choose which equation works, check. Substitute and create your equation, and then get your answer showing appropriate steps. Here we go. Continuing on, page 8. Find the following sums. Well, we want the sum of the first 24 terms here. So here we go. Sum of the first 24 terms, we don't know. That 24 tells us we have 24 terms in this series that we want to work with. We know the first term is 1/12. What else do we know? Well, so I can come up with my D value. Again, my 1/2, I want to make everything common denominator. I'm just going to turn my 1/2 into 6/12 because 6/12 is equivalent. How does 1/12 become 6/12? Add 5/12. 6/12 plus 5/12, 6 and 5 is 11/12. So our D value is 5/12. So there's the information I know. Do I know the last T of n term? I don't. So this formula doesn't help me because I don't know T of n. So there's the formula we're working with. We want the sum of the first 24 values, knowing we have 24 terms, times 1/12, T1 times 2, plus n minus 1 times the D value of 5/12, and all of that needs to be divided by 2. So again, you might have to break it down, might have to do a little bit of extra little steps to help. Depends upon you and what you require, but you need to figure out what works for you. So with that being said, what can I do? Well, S24 equals 1/12 times 2, which is 2 over 1. 1 times 2, 12 times 1 is 2/12, which reduces to 1/6. 24 times 1/6 plus 24 minus 1 is 23. 23 times 5/12. Well, 23 times 5 is 115. So we get 115/12. And all of that is over 2. So it's fraction work. Calculator, you can do it. Whatever works for you. So in this case, 1/6 plus 115/12. Well, 1/6, if I get a common denominator of 12, becomes 2/12 plus 115/12, which is 117/12. So this is 24 times 117/12 divided by 2. So our S of 24 value becomes, after all is said and done, 117. There's the sum of the first 24 terms in that series. Choose your formula and work with it. All right, so now example 2. Still, just trying to find a sum. Let's list what we know. Find the sum. All right, that's what we want to do. However, this case, we know that term 1 is -8. What else do we know? This one's different. This ... tells me there's a bunch of information, but we finish at 72. So this time we know the last term is 72. What else can we get from this? Well, -8 to -4 is +4. -4 plus 4 is 0. Plus 4 is 4. So we know our D value is 4. We don't know what N is, though, because we don't know how many terms there are. That's all we have this time, but look. Which equation will work? Well, we know T of N, we know T1, but we don't know what N is. All right, so the second equation, we know T1, we don't know N, we know D, but we don't know N again. We don't know N, and it's required in both. If the number of terms isn't given, we want to use T of N equals T1 plus N minus 1D. This formula needs to be used first to figure out what N is. Because we do know T of N is 72. We do know term 1 is -8. N minus 1, and we know that D is 4. So sometimes you get a two-stepper. You need N for both equations. If you don't have N, you need to solve for it. So from yesterday's lesson, distribute the 4. Combine your like terms, and then solve for N. So 4N is equal to 72 plus 12, which is 84. So N is 21. So in this case, we have to calculate that N, which is 21. Now I know T of N, I know T of 1. Now we know what N is, so that first formula works nice. So the sum of the terms is N 21 times -8 plus T of N 72, all divided by 2. 21, -8 plus 72 is 64, and we're going to divide that by 2. Divide that by 2, and we get 21 times 64 divided by 2, 672 is our sum value. So when we list what we know, remember, N is important in both of these. If we don't have it, there's an extra step required. Pause the video, give this one a try. Same question, basically. See what you can come up with. So again, T1 is 3. Tn is 143. D, we can see from term to term, is increasing by 4, but we don't know N. So we use our term formula, which is 143. T of N equals term 1 plus N minus 1 times the D value of 4. Like we've been doing to solve for N last day, combine your like terms, and N works out to be 38. So we know with 38 terms now, oops, sorry, not 38, 36, my bad, too much in my head. 144 is 36, so sorry about that. So we know that N is 36 now because of the extra step, because that N is essential in both. Now we have T of N, we have T of 1 and N. That first formula can be used. Number of terms is 36 times 3 plus 143 divided by 2. 36 times 146, and then divide by 2, gives us a value of 2,000 2,628 is the sum of this series. Add all those values, 2,628. Know what you have, figure out which formula, and then solve. Question 4. Like one from yesterday, we want to find the sum of the multiples of 6 between 24 and 396 inclusive. So include the 24 and 396. So the question is, like yesterday or last lesson, do we want to work with 24? Yes, because 24 is a multiple of 6. 396? Yes, it is a multiple of 6. So we have 24. The next multiple would be 30. The next would be 36. The next would be 42 plus ... We want to add up all of these terms. So what do we know? Term 1 is 24. Term 2, or we don't need term 2, sorry, term n. The last term is 396. We know because we're dealing with multiples of 6, our d value is 6. The problem is still, same as the last ones, we don't know how many terms there are. We need to figure out how many terms so we can use, because both equations require the number of terms. So 396 equals term 1 plus n minus 1 times d. 396, distribute the 6, combine your like terms, and then get n by itself. Subtract 18, divide by 6, and n works out to be 63. Now that we know that n is 63, so there's 63 terms in this series, we want the sum of those 63 terms, knowing that 63 terms, term 1 is 24, plus 396, which is our last term, divided by 2. Choose the easier equation. 63 times 420 divided by 2. That works out to be 13,230. That's the sum of the 63 terms. But question from yesterday with this idea of multiples in your sequence can be incorporated into a series question as well. So lots to think about. Here we go. Example 5. Example 5 you have to be a little careful with because of the labeling. So we have T1 is 17. We have T38 to be 128. But we want the sum of 53 terms. So our Tn, the last term we have, is only for 38 though, not for the 53 we need. So technically, we want n to be 53, but right now I only have information for 38. You need to be attentive to what's given to you. So again, it's going to be a two-stepper because I can't work with T38 and S53. They're really not the same. So I have to think of this as being two separate questions. I've got S53 over here as a second question with n being 53. But over here, what do I still need? Well, we're starting with 17 and we're adding a whole bunch of numbers, and we know eventually we're going to add 128 in there, which is our 38th term, but then we're going to add a whole bunch of more numbers till we've added 53 numbers. So what's important? We still have term 1 of 17 over here. So what do we have? We know we have, well, for our final, we know we have 53 as n. We know we have term 1, but we don't have the last term. So that formula doesn't help us right now. If I take a look, we have n. We have t1. We have n. All we're missing is d from that second term. So what I can do, doesn't matter where I'm stopping or starting, this d value from term to term is going to be the same. So I need to calculate d here using this information. Again, to solve for d, I can just work with our t of n formula, because that has information that will allow me to solve for d. Because t of n, I can use 128, because I'm not focused on the 53 right now. So the 38th term is 128. The first term is 17. We don't know how many terms, or do we? We know it's term 38. So we have 38 minus 1. We have that n because we know we're dealing with the 38th term here. So that's important. And with that being known, I can then solve for d. 128 is 17 plus 37d. Subtract 17 from both sides, divide by 37, and we get a d value of 3. So our d value from term to term is a positive 3, and that will be the same thing if I'm adding or whether I'm just listing. So now I can go back. I now have 53 terms. Term 1 is still 17. We don't know our last term, so that doesn't help. We know we have 53 terms. Term 1 we have 53 terms, and d is 3. So we have to use the second formula in this case, because that's the information that's been given to us. There we go. Have everything we need now in the second equation. So now, a couple little steps here. 2 times 17 is 34. 53 minus 1 is 52. Times 3 is 156. Divided by 2. So the sum of 53 terms, add 34 plus 156, times by 53, divide by 2, we get 5,035 as the sum of the first 53 terms. Be attentive to what information is given so that you're using the appropriate values. Now, here is where we have a practical application of this. I mean, I think of it every time now that I've seen this, and I remember this from a kid, that every time I see a stack of cans in the supermarket, oh, I could figure out how many cans are in there without counting everyone. If we think of it, if there's a stack of logs, and on top there's 3 logs in row 1. So there's row 1. Row 2 has 7 logs. Row 3 has 11 logs. So I don't know exactly if that's 11, but we end up with this big stack of logs getting bigger as we go to the bottom with all these logs being stacked. So there we go. If they're stacked consistently, well, then we can figure out easily some information. Stack of logs, 3 of them in row 1. So our term 1 is 3 because there's 3 logs in the top. Term 2 is 7. I don't necessarily need term 2, but I know I'm going from 3 to 7. Term 3 goes to 11, and so on. What does that tell me? Well, we can see that we're adding 4 logs every row. And it says there are 271 logs in the last row. So we know we're going to keep adding until we have 271 logs along the bottom of this stack. I'm not going to do 271 of them, but you get the idea. So what does that 271 represent if there's that many in the last row? That's our Tn value. The last row has 271. So T of n, not T of 2, sorry, T of n is 271. There's the information I know. So now that we have an idea as to what's going on, now we need to solve some questions. First question is, how many rows? What's that asking? Well, that's asking for n. Because term 1, there's 3 logs in row 1, 7 logs in row 2, 11 logs in row 3. So how many rows are there? Well, that's the last row has those 271 logs. So we want to know n, how many rows? And then the second question is, how many logs? Well, all the logs together, if there was 3 of them, and then 7 of them, and then 11 of them, what do I have to do to know how many logs there are? And then there's 271 along the bottom. I need to add up all of those. So this second question is an S of n question. So I'm going to start to calculate n first. Because what do I know? Well, I'm not dealing with the sum right now, but I know T of n. So this is going to be our term equation, because that, knowing there's 271 as my last term, is what I can deal with. 271 equals term 1 plus n minus 1, and we know we're adding d or 4 each time. So here we go, solve for n again. Been there, done that. So in that case, n is 68 when I solve for n. 68 rows of logs. So I can add n is now 68. So what is this question asking? If we want how many total logs? We want the sum of all 68 rows. Well, which equation will work? Do we know n? We do, 68 rows. Term 1 is 3. Last row, term n is 271. First formula works nice. S of 68. Number of rows, 68, times T1 plus 271 Tn, all divided by 2. The sum of 68 will be 68 times 274, because I add that, and then I'm going to divide by 2. So the sum of all 68 rows is 9,316 logs stacked together. That's a lot of lumber. But there's an application. So, 2 new formulas, solving the same thing based on what's given. Well, now we get to questions like first lesson that isn't just about find the sum. Because now we have situations where we can solve for an unknown. So it tells us the sum of the first 12 terms of an arithmetic sequence is 228. So the sum of 12 terms is 228. There you go. It tells us the sum this time. It tells us that D is equal to 4. So we know that N is 12 because we have the sum of 12 terms. So we want the first 3 terms. Well, the first 3 terms is going to require to know what term 1 is, and then we can just add our D plus 4 to get the others. So we're trying to find term 1. So we go back to our equations. First thing that's important to know is we have the sum of that is given to us. We know there's 12. We know, we don't know T of N. We don't know the last term. And we don't know T1. So this formula doesn't help. But let's check second formula. We have the sum. We know there's 12 terms. We know term 1 is 4. We know there's 12 terms, and we know that the difference is 4. So there's the equation we want to work with because we have all the information. Algebra is going to be a little bit more involved here. So with this equation in mind, the sum of 12 terms is 228. That's equal to 12 times 2 times T1, which we don't know, plus N minus 1 times D, which is 4, and all of that is divided by 2. So there's our equation, and here the T1 is what we're trying to look for. Oh, lots of things to get rid of to make T1 by itself. How I would start this, I would start by multiplying by 2, because multiplying, if I'm dividing by 2, I multiply by 2, they cancel out, and I multiply by 2 on this side. That leaves me with 456 equal to, well, I still have all this stuff up here in the numerator, but I am going to simplify a little bit. I have 12 times 2T1, but I'm going to do 11. 12 minus 1 is 11. 11 times 4 is 44. I'm going to simplify by doing that first. So I've gotten rid of the 2. Because it's divided by 2, I multiplied by 2 because it cancels out, multiplied by 2 to keep it balanced. And I did a little bit of combining here to get my 44. At this point, well, I'm dividing by 12, or multiplying by 12, so I'm going to divide by 12 to get rid of it. That will leave me with 38 equal to 2T1 plus 44. What do I do to get T1 by itself? Subtract 44. Leaves me with negative 6 equal to 2T1. Divide by 2. And term 1 is equal to negative 3. What are the first 3 terms? Well, we've just solved term 1 to be negative 3. We know we have a D value because it was given to us as 4. So negative 3 plus 4 is 1. 1 plus 4 is 5. There's the first 3 terms. So, first question we looked at where the sum was given, and then we had to do some algebra because we all love algebra. All right, take a look at this one. Pause the video. See what you've got. Give it a try. Go. All right, what do we have? Well, again, sum of 30. It tells us that this time. That's important. An arithmetic series. Term 30 is 58. Well, what's nice about this, a little different than the last one, we want the sum of 30, so we know the last term. So that's helpful in this case. What else do we know? Anything? We want to know what term 1 is. That's what we're trying to find. What else do we know? One more piece that's important. If we want the sum of 30 terms and we know what the 30th term is, we know that n is 30. The little subscript tells us what n is. So do we have the sum of n? We do. We know there's 30 terms. We're trying to find t1, and we do know the last term, t of n, which in this case is our t of 30. So that first formula will work nice. So we plug into it. S of n, sum of our terms is 1,095. That equals n, which is 30, times t1, which we don't know, plus t of n, which is 58, and all of that divides by 2. Again, there's different ways to approach this. If you mathematically can do it correctly, go for it, because there's other ways to look at it. I'm just showing the method that I default to. It's divide by 2, so I multiply by 2, cancels out. Multiply by 2 to keep it equivalent on that side. We're left with 2,190 equals 30 times T1 plus 58. At this point, 30 times that, so I divide by 30 to cancel it, divide by 30 to cancel it. This leaves us with 73 equal to T1 plus 58. Subtract our 58, and term 1 is 15. And there you go. So a different version. What's given is the sum. So we need to pick the right formula and then do a little bit of algebra to solve for the unknown value. Number 9. I'll be honest with you, I'm not overly concerned with number 9 and number 10. They're there as interesting questions. You can try them, but the key is for both 9 and 10 in the booklet, if you want to try those, honestly, they have nothing to do with the sum of numbers. That's kind of why they're put into the booklet. Students will jump into the SN calculations, but neither sum is given, and it doesn't ask for the sum. Both question 9 and 10 are really just focusing on the formula, the sequence formula. So because these videos are a little bit longer, I'm not concerned with it, but if you want to try them, give it a whirl, but remember or consider what's given and what you need. In 9 and 10 number, question 9 and 10 both, it's really a sequence question as opposed to a series question. Number 11, hardest question you're going to see, I think, in this whole particular chapter. This builds on the same idea as one of the questions from the last lesson, where we have to use a system of equations to solve. Because we're not given a lot. We're given 2 sum values. And all we can really pull out of that besides the sum is I know in this case that n is 2, and in this case that n is 6. I don't know term 1 or term n. I don't know d, and I don't even know term 1 or d, so it's too much unknowns. So what I have to do is I need to create a system of equations by creating an equation for each of these. And I need 2 unknowns, so in these cases, here's the system, or the equation I want to work with, because I can then create an equation with T1 and D and then solve for T1 and D using a system of equations, 2 equations. So here's how it looks. For the first one, the sum of the 2, we know it equals -1. So we know that equals -1, and therefore we also know that n is equal to 2 because it's the sum of 2 terms. So I want to take this second formula and try to simplify it as much as possible. -1 equals 2 bracket 2t1 plus n, which we know is 2 minus 1, times d, which we don't know, and all of that is divided by 2. So I've taken the second equation, plugged in the s of n, and plugged in the n value where I could. Let's simplify. Well, like we've been doing, multiply by 2 to cancel, multiply by 2. So we have negative 2 equal to. I now have 2 bracket 2t1. 2 minus 1 is 1. 1 times d is just a d. And now I divide by 2. Divide by 2. I have negative 1 equals 2t1 plus d. Nice, simplified formula. This big ugly thing here simplifies down to that equation. Well, I now want to do the same thing for s of 6, which equals 81, knowing that n equals 6 because it's the sum of 6 terms. So here we go again. 81, the sum of the 6 terms, is 6 terms, bracket, 2t1 plus 6 minus 1 times d, all divided by 2. So I took my equation, plugged in the s of n, plugged in the n where I could. Now I just want to simplify. Well, I'm going to multiply by 2 to cancel, multiply by 2. 162 equals 6 bracket 2t1 plus 6 minus 1 is 5. 5 times d is 5d. Divide by 6. Divide by 6. We get, what do we get there? Sorry, 27 equals 2t1 plus 5d. So there's our second nicely simplified equation. Now that I have two equations that represent t1 and d are the same in each, first term is the same in each and d is the same in each, now I can solve the system, and I like to do it using elimination. I'm going to multiply this second equation by -1, which will create a negative 2t1 paired up with the positive 2t1. So -1, my first equation will stay the same, 2t1 plus d. But my second equation, I multiply by -1. -27 equals negative 2t1 minus 5d. 2 t's and negative 2t1 cancels. Combine the rest. Negative 28 equals negative 4d. Divide both sides by -4. And d equals 7. So we get d equal to 7. And now I'm running out of room. Let's finish it down here. If d is equal to 7, I'm going to plug d back into this formula. -1 equals 2t1 plus 7, because d is 7. Subtract 7. Divide by 2. -8 divided by 2. t1 is -4. So we end up with t1 equal to -4 and d equal to 7. That is math at its finest. Unfortunately, it becomes tough to recognize when to do something like this, but the key is not a lot of information is given at the start. We don't have a bunch of things, but we see that we have a t1 and a d missing. That's two unknowns. It'll be the same. I can solve two unknowns when I have two equations in a system of equations. So when I can create two equations with the same variables, I can use a system. Beautiful stuff. There is your assignment. Lots to think about. It's repetitive. This practice needs to be done. There's all kinds of different ways, and that's why these videos are so long. There's so many different formulas and variables that could be solved for. It's the same thing repetitive, but it's knowing and being able to utilize your algebra skills effectively. The only way to get good is to practice, folks. Have fun with it. Enjoy.